Okay, this will be the final video. This is going to go over molecular or covalently bonded things. So just a reminder, covalently bonded things means that you're looking for something that has two or more non-metals. Okay, so it's only non-metals. There will not be a metal involved in this. And this also means that your electrons are being shared in order for everyone to try to meet their full octet or their full outer shell. Covalently bonded things are going to be named using prefixes. So one important thing that you got to be able to do is know all your prefixes. So just to have them written down, we're going to be using mono for 1, di for 2, tri for 3, tetra for 4, penta for 5, hexa for 6, hepta for 7, octa for 8, nona for 9, and then deca for 10. Okay, prefixes means in the front, okay? And we'll kind of review a couple extra rules as we go through these examples. Okay, so to start us off, we're going to start with carbon tetrachloride. So one thing I want you to notice is there is no prefix in front of carbon, and that's because we don't put anything in front of the first one if there's only one of them. Okay, so this is telling you that we have 1 carbon and then we have 4 chlorines. So this we would write out CCl with a little 4. Okay. Now when we go to draw the model for this, I kind of reviewed this a little in class, but I'm going to try to walk you through at least 4 examples to make sure you've got it at home. So I do require you guys to use needed, available, shared in order to draw your different molecules. And so just a review of what this means. Needed is basically what does it mean to have the full outer shell. So for the most part, this number is going to be 8. A couple exceptions to this is hydrogen only needs 2, beryllium only needs 4, boron only needs 6. Other than that, the answer to that question is going to be 8 for each atom. Okay. Available is going to be your valence electrons. So at this point, you should be able to do that. Shared is how many of these electrons have to be shared in order for everyone's octet role to be satisfied. We take that shared and we divide it by 2 in order to figure out the number of bonds. Okay, and like I said, I do require you to use this even on the easy ones so that when we get to the hard ones, it's not going to be so difficult. So I'm going to move this up here so that we have that to refer to. I'm going to rewrite my formula here, CCl4. Okay, and what I like to do is sometimes I like to write out Cl, 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 Cl so that I can keep track of my numbers. Okay, so I'm going to write N minus A equals S. So for needed, this first carbon, he's kind of a normal one. He's not any of these exceptions. So he needs to have 8 in order to be considered full. Chlorine needs 8 to be considered full, as do the rest of these. So when you add all those together, you have 8 times 5, which would be about 40. Now we're on to our next part. Carbon is found in group 14, so that means that he has 4 valence electrons. So 4 valence electrons, and then each of the chlorines have 7. So I'm going to say 7 plus 7 plus 7 plus 7. Those all together equal 32. I'm going to do subtraction. 40 minus 32 would be 8. I'm going to divide by 2 in order to figure out that I need 4 bonds. That's what we're going to start with. So when you're given a compound, put the oddball in the middle or the least electronegative. The least electronegative, so the furthest away from fluorine. So for this one, carbon happens to be that one. He's the oddball and furthest away. So we're going to put carbon in the middle, and we're going to draw the chlorines kind of around it. Okay? I'm going to draw 4 bonds. So here's my first one, second one, third one, fourth one. Okay? So I've now indicated all the bonds, but now I have to add in all the valence electrons. So I'm going to refer to this number right here, my available. My picture has to have 32. But remember, each of these bonds counts for 2 electrons. So when you go to count it, you would be saying 1, 2, 3, 4, 5, 6, 7, 8. So my carbon is complete. I have 8 there. And then I would continue adding these little valence electrons. 9, 10, 11, 12, 13, 14. My first chlorine is full. 15, 16, 17, 18. Oop, I think I'm off the screen there. Sorry. 18, 19, 20. So this one's now full. 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, and 32. So your final answer is actually going to be this little drawing right here. Okay, so that is carbon tetrachloride. So just a quick recap, we added together what they all needed in order to be considered full. Then we added their valence electrons. We subtracted those in order to figure out the number that were going to be shared, which we can see here, 1, 2, 3, 4, 5, 6, 7, 8, divided by 2 to figure out our bonds. Once we got our bonds drawn in, we went ahead and went back to this 32 and made sure we had 32 electrons shown. Always double check each atom to make sure you've got 8. So looking here, this one has 8, this one has 8, this one has 8, this one has 8, and this carbon has 8. Everybody is happy. Okay, I will move a little bit quicker on this example so that this video isn't super long, but I am going to go ahead and we'll start with our formula. So this would be technically dioxide, although because it's part of the diatomic 7, we actually just call it oxygen. But we're going to go ahead and go with the rules. So we got O2. I'm going to set myself up for needed, available, shared. Okay. I know that each of the oxygens needs to have 8 in order to be considered full. So 8 plus 8, which will give me 16. Available, each one has 6. So now I have 12. 16 minus 12 equals 4, divided by 2 would tell me that I have 2 bonds. So they're the same thing, so I'm just going to put them right next to each other. And this says that I have 2 bonds, but I don't have very many places. I only have 1 spot to put that bond. So I'm going to make a double bond. Okay, each of these has 2 electrons. So I have 1, 2, 3, 4. I need to have 12 total. So 4, 5, 6, 7, 8, 9, 10, 11, 12. So notice that we are putting them in pairs, okay? And you can kind of see that I'm kind of trying to make them as symmetrical as possible, so pushing them away from these bonds in the center. That's because those electrons are going to be repelling it. So this would be your final answer right here. And you have a double bond, and you double check that everybody's full. This one has 8, and this one has 8, so we are all good. Okay, our next example will be one that looks very familiar. This is water, but making sure we use the right naming. We have 2 hydrogens, so we're going to say dihydrogen. And then we have only one oxygen, monoxide. It would be monooxide, but we would take away that first vowel, so monoxide. Okay. Using NAS, this is one that has hydrogen in it. So remember, hydrogen only needs 2 electrons in order to be full. So each of those are getting a 2, and then the oxygen needs to have 8. So 8 plus 2 plus 2 will give me 12. Available, each of the hydrogens only have 1, and oxygen has 6, so I have 8. 12 minus 8 is equal to 4, divided by 2 means that I have 2 bonds. So for this one, I'm going to go ahead and put the oddball in the middle, which is oxygen. So I'm going to put oxygen in the middle. I'm going to draw my hydrogens off on the side. Okay, I'm going to make my 2 bonds. Okay, remember, each of those bonds represents 2 electrons. So I have 1, 2, 3, 4. I need to have 8. 5, 6, 7, 8. And now I'm done. Notice I did not put anything on the hydrogen, and that's because hydrogen can only have 2. Since it can only have 2, that means that this was full, and this one's full just by that bond. And then oxygen has 8. So there's all the sharing going on. Okay, and we will end this video with something. We're going to end it with CFCl3. So the name for this would be carbon. We don't put a mono. Monofluorine. Trichloride. Okay, so yes, we can have more than just 2 different types of elements. When we go to draw this guy, needed. Carbon needs to have 8. Fluorine needs to have 8, and each of those chlorines needs to have 8. So we're at 40 available. Carbon has 4, fluorine has 7, and each of the chlorines have 7. So we have 32. 40 minus 32 is equal to 8. Divided by 2 means we have 4 bonds. So I told you guys that either the least electronegative or the oddball. Well, we have 2 oddballs, so we're going to go with our least electronegative, which would be carbon. We're going to put carbon in the center, fluorine, and then we'll put our chlorines around it. Okay, I'm going to draw my 4 bonds. And then just like our first example, we have to have 32 electrons total. Each of those bonds represents 2, so I have 2, 4, 6, 8. Now I'm going to go around. 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32. And now we're done. So hopefully this helped. Just come see me if you need help.